we're going to be addressing this to-do today. Use arena allocators instead of temp allocator. For heap initialize, I'm using a temp allocator. So I'm using the allocation scheme, and I'm using the temp allocator from there. I want to replace this with my arena. Same thing here, came from. Same thing here, cost so far. In theory, we're going to have multiple enemies or just entities on the map. And so per frame, we're going to call next step forward. Let's say we have n entities, right? We're going to call next step forward maybe n-1 times, because one of those entities might be the player, and the player will be controlled. I mean, I could even be animating a cutscene or something like this and just doing auto pathfinding or something like that. So I mean, it could run up to n times, for example. And so if we're calling next step forward n times per frame, we're talking multiple kilobytes of memory being used. My backing temporary storage, if I wanted to, I could make it on the order of gigabytes. It's probably totally fine. Right now, it's on the order of like 2 megabytes or something. It doesn't need to be that small. I just make it that small so that way, once I start pushing up against the memory limit, I'll have an idea kind of how much memory I'm using. I basically just don't expect a lot of expensive memory operations right now this early in development. So if there is something like that, I want to catch it early. What I'm thinking is in our temp allocator, we're actually going to allocate another allocator. We're going to allocate an allocator inside the allocator. Because yo dog, I heard you like allocators kind of thing, right? And we'll call this in a loop, basically. Like for each entity, we'll loop over the entities, and we'll call this once per entity, for example. Right before we call this, we will reset, or maybe right after we call it, we'll reset the storage of the allocator that we pass into here. And so essentially, the maximum amount of memory used by one call to this, that will be the maximum amount of memory used by the group of calls to this per frame. Enemies.data is the address of game state enemy, and enemies.count is 1. For enemies, we're going to keep dest found outside the scope and mutate it inside the scope because we know that we're only iterating one time, and I'll clean that all up once we actually iterate multiple times. So now that we have that, what we need to do here is set up a new arena. And the trick though is that we can't just use our arena as is. We actually need to implement the JAI allocator interface, this guy right here. We need to implement this for our own arena. They call it an allocator proc. So we'll call it an allocator proc. In fact, we'll call it a arena allocator proc. We're going to take an allocator data. It's a void pointer, so we cast that to a pointer to arena. Here's what the modes do and which parameters matter when. So for allocate size bytes with the heap represented by allocator data. Let's go up here to alloc. Alloc operates on our arena and takes num bytes, and it returns a star U8. I forgot that void is a thing in this language, so I need to change these interfaces to like star void or something probably. Arena out of memory. This actually needs to be like caller. Like I need to capture caller location or something maybe, because I'm just going to print arena out of memory, and I'm going to print the line in the file, whatever, for this JAI arena allocator proc, but it's not going to say the arena name or anything like that. Someone might call free. In fact, we are going to call free right here when we call dinit and destroy. It probably pays to at least just print warning attempted free with arena allocator. Startup. This allocator proc has not yet been used. The program or DLL is starting, or we are going to start using this allocator within the program. Please initialize whatever global stuff you need to initialize. All parameters are ignored, including the allocator data. I think we're still going to assert. And the shutdown is probably similar. Resize is to do. Thread start, thread stop. This, we should never be calling these. So for now, I will still assert. Create heap with arena allocator. Is this yours? Okay, this is interesting. If the memory location past an old memory was allocated by your heap and is currently live, return 1, otherwise return 0. All other parameters are ignored. I could easily check that, but I'm just going to assert on that. I don't want to support that. And then caps returns the capabilities of this allocator proc as allocator caps. Because it's just me using this, I think we're going to skip this guy. I have no idea if like caps is going to be called on us. Essentially what we support is allocate and resize. Thread equals null, print, build the resize with the arena allocator. Now the question is, how do I integrate it? We pack it into a struct, and then I set that struct on the context. We'll create the allocator on the stack here. we'll take a pointer to it here. First, let's create the arena for pathfinding. Dude, let's just make it like 10 kilobytes or something. There's a bug, right? I'm pretty sure on the master branch, I clear the temporary memory. We need to make sure to reset our temporary memory here. I should probably align my integer types with JIs. So let's see, we set up an arena on the stack. We give it 2 kilobytes of storage, and then we set its size to 2 kilobytes. Its count, or whatever that was called, used is default initialized to 0, so that's good. Now we need to create an allocator. An allocator is a proc and a data. Data is going to be cast to void star, the address of pathfinding arena. And the proc here, I guess, needs to be this guy. It needs to be JI arena allocator proc. I see. I overload. Oh, God. I overload alloc in the scope. Number signedness mismatch. This I don't expect. Oh, I was never calling that. I was never calling that, so it wasn't getting type checked. Now I just want to run this and make sure that we're not closing memory or anything like that. So I just want to make sure the memory it should never really increase. Well, I shouldn't say that, because I mean SDL itself is going to do some stuff. I don't constrain SDL's memory, but I don't really see anything blowing up here. We need to set this on the context. Let's get rid of our allocator here. So we don't use allocator temp here. In fact, we just don't specify the allocators anymore. This is kind of wonky now that I think about it. I'll explain why. We'll get rid of all this stuff. Because like, there's now implicit knowledge in this function that we're getting a special allocator coming through the context. And so we should not call dinit or destroy, because that's going to call free. And free is going to, what is free going to assert? Free just prints a warning. So I could do it just to demonstrate it. But really, we don't want to call any of these things. And again, it's implicit knowledge, because I can add some documentation here saying that we expect to get like a temporary allocator set as the primary allocator in the context. But really, I think actually what we should do is take a JI allocator, or just an arena, maybe. I don't know. Like, I feel like we should take it explicitly here as a parameter, and then we set the context inside of here. I'll have to think more about that design. Let's just stand it up and get it working first. Allocator is pathfinding allocator. Arena reset. Does that work? No. Out of memory. I got an out of memory. How much memory was I allocating per frame? Yeah, 2 kilobytes. That doesn't surprise me. I wanted 10 kilobytes. So, okay, there we go. Okay, so 2 kilobytes does not surprise me. Because as we did back of the envelope calculations, right? The tables are probably going to be pretty large. The heap alone is, what did I say? It's about 1 kilobyte. So that was like 50% of our temp arena. Okay. All right. So I just flubbed the math here. All right. Do this really unscientific test here just to make sure we're not leaking. So something interesting happens with the res, right? Like the resident memory. And I think it's from SDL. So I'll kill this. I'll come back here. I'll start this. Jump over here real quick. The res is, okay, increasing. I'm not doing anything, right? So it increases a bit, 65,332. If I come grab this and I play a little bit, it goes up a little bit further, and then it eventually caps. I think that's just SDL, especially with rendering. The JI API is totally fine. I respect it. And now we understand kind of how it works. That's really cool. So if I come down here, we're gonna get spammed. Okay, I expected us to get spammed. However, arena out of memory. Oh, whoa, yo, this is awful. Okay, so this is exactly what I expected. We're gonna get spammed with messages here. I would love to see this fail. Okay, good. All right, so it failed even with the deallocators commented out. Okay, so I guess I would just need to run this in the debugger multiple times. Does this have to do with like spawn location or something? I have a theory. It's probably running out of memory on a realloc. What I'm thinking is resize probably gets called when the enemy's far away, because the further, the size of the data structure, the amount of space required is dependent on the path length. If I set this to 10, here is where we should see reallocs happening. No space left in heap. Oh, okay, but that makes sense because the heap itself is not going to resize. And then missing 2 and came from while rebuilding path. Segfault. Okay, all right, we got a failure here. This is great. So first of all, where are we? Okay, new array in the hash table. All right, now just because we're failing here doesn't mean we're always failing here every time we've seen it fail before, but it's the only thing we have to go on. I should probably also capture core dumps, so that way I have like I can reproduce these things. What is it trying to alloc? Table slots filled plus 1 times 100 is greater than the table allocated table, then we expand. Okay, expand table. A beta user requested being able to call expand, so here. All right, old entries, table entries, new allocated. Yeah, so here we go. So we start allocating right here. Interesting. Yeah, this could just be blowing up memory, internal resize memory. Let's see what's going on here. And we're just getting a new array because this is the backing storage for the hash table, right? An array. Maybe it's not a bug. It might just be the case that this thing is hungry for kilobytes. I'm going to go back up the stack and I'm going to look at enemy position and I'm going to look at player position. I suspect they're going to be far apart. Then I'm going to force them to be far apart, which I could have just done in the beginning. I'm going to put them on opposite sides of the map. Then I'm going to run the game. And I expect a crash. I expect an out-of-memory crash. And if I get an out-of-memory crash, that explains what's going on. The fact that realloc or resize is not called, well, I don't have any opinion about it, but I expected that to be called. I'm curious what we're doing with the old memory. Info locals, right? N is 256. N is next pair of 2. So 256, like what's the size of entry? A key type and a value type. Okay, so for us, this is 4 bytes. And then a key type is our vector, which is going to be 8. And then a value type is also 8. So 20 bytes, and N is 256, 5K. Yeah, that'll do it. Even if this did call resize or realloc or whatever, as we saw from the implementation of my allocator interface, I don't do anything with the unused storage. So that would still be a problem. Print from, print to. Okay, so let's just copy this and we can reproduce it. And in game.jai, we will force the positions. Oops, let's see. Boom. So this guy here and player, let's say player is at 8.0 and then 17.0 and 30.0, 8.0 for the enemy pause. I expect a crash and it doesn't crash reproducibly. Order probably matters for search here, because that will determine how the frontier expands. It's enemy to player. Let's try this again. Build this, then run it. Yes. Reproduce, yes. Reproduce like rabbits. Thank you. I mean, obviously, if I just increase the storage without having debugged this, that could appear to fix the problem. What if we just have 20 kilobytes? Oh, and I still ran out of memory. What's attempting to free? It might be the hash table. So there we go, right here. This is in expand, which is getting called. We saw from debugging. We don't do anything. So I don't actually need to print a message. It's not a problem that free is called. We just don't do anything with free. Well, this should be reproducible. There we go. And it's when I try and go down. If I go right, that's fine. If I go left, that's fine. If I go up, that's fine. It's just trying to resize again, right? It's probably trying to resize again. GDB build 0. Run this guy and then press down and we get a seg fault. So next step toward table add, expand, internal resize. We're expanding again. Let's go take a look at what we're doing here and expand. Info locals, 512. So it was 256, now it's 512. 40 kilobytes. I'm just gonna call it 20 kilobytes. Distill seg faults. But now there's no space left in the heap. This is different. We're not using our allocator for this. That's pretty wild. The frontier is pretty big. Heap size, 200. And now it's a arena out of memory. We got some bugs. I got bugs all up in this place. I'm gonna go debug it and then we'll figure out what happens and I'll share that in the next iteration. Thanks for joining in. Peace.